Hello and welcome back to the 6th week of Consider This, a new virtual series where we simplify the science and public health behind COVID. I'm Marianne McDowell.
Hi, and I'm Heidi Beidinger, and we're co-hosting this new webinar series focused on the pandemic. Our guest today is Bibby, and Kyle is an engineer who's testing wastewater for SARS-CoV-2. We'll introduce him shortly, but first, and as a reminder, our goal for this webinar is to help our community's understanding of public health and science as it relates to COVID.
So we hope you're finding the information in the series informative and are passing the information on to others. And as I remind you every week, you can email us at consider@nd.edu with questions and comments. And I also want to remind everyone that we bring in the experts to give you expert advice, but the views presented are the views of the experts, of Heidi and myself, and not explicitly the views of the University of Notre Dame. A lot of times we'll talk about health information and the information is not provided or intended to serve as, nor should it be interpreted as specific medical advice for you or a substitute for the advice of your individual personal health practitioner.
So last week we had a great conversation with Jenna Colson and Alex Perkins. We talked about epidemiology and modeling during this time of the pandemic. But don't worry if you missed it, because of course, as always, we have it posted on our ThinkND webpage. So last week, we actually received a question from Mary Maisel from Carrollton, Texas, and she wrote this: "Really enjoying the science lessons, thank you. Will the moderators tell us what their superpowers are before the series ends?" So I guess we should probably share with the audience what our superpowers are. So I'll go first. My superpower is optimism. My glass is always half full, always.
Oh, I would attest to that. I'm like down and complaining. You always bring me up with your perspective. So thank you. My superpower is that I'm super at making creative cocktails. So I make really mean jalapeno pomegranate martini.
Okay, so if I had to have a second superpower, my second superpower would be that I'm really, really good at sampling Marianne's cocktails.
So maybe next time we'll each have a cocktail. We'll see.
Yes.
We've also been receiving over the last 5 weeks lots of questions about our outfits, our hair, if we coordinate. The answer is no, but I guess it's just great minds think alike.
That's right. Exactly. So here we are now in week six of our series. So let's bring on our guest. And here he is. Hello. Hi, Kyle.
Hi, everybody.
We're so pleased to have you here and introduce you. Kyle is an associate professor and a Wanzek Collegiate chair at the University of Notre Dame in the Department of Civil and Environmental Engineering and Earth Sciences. He completed his undergrad in civil engineering here at Notre Dame and his PhD in engineering from Yale University. Kyle has a passion for water quality. He currently leads multiple research projects investigating microbial water quality and microbial communities in the built and the natural environment. He also happens to be a board member of the St. Joseph County Health Department Water Quality Advisory Board. So welcome and thank you, Kyle, for joining us.
Yeah, thanks for having me. Glad to be here.
Yeah, thank you so much. We're really excited to hear about the research you're doing and just about water quality in general. But before we get started on that, Heidi and I always ask our guests to talk about their discernment process of what got you interested in what you do. Why did you decide to become an academic? We have lots of students that listen to the webinar series, and I think that your journey would be interesting to them.
Yeah, sure, gladly. So when we talked about this webinar and I thought about this question, I was sort of chuckling because I actually asked the same question to the juniors that I'm currently teaching at the beginning of this seminar. And my answer for why I began studying what I did isn't too different than many of them. So I've always loved being outdoors. I've especially always loved fishing and hiking, and I have always had a great appreciation for the environment and for water quality. I also have always really loved science and the idea of applying to achieve a goal, to solve a problem, which is really what engineers do. So you put those together, and really I kind of came in maybe a little unsure when I came into undergraduate what I was going to do, but environmental engineering, which at that time was a subset of civil engineering, now it's a separate major. It was a pretty natural fit, being able to apply science, math to solve some environmental challenges. And like I said, it's really not too different of a story than many of our current undergraduates. It's sort of a fits that way nicely. As far as how I became an academic, I actually didn't think I was going to be an academic. I really enjoyed undergraduate research. I just like getting my hands dirty and doing stuff. And the problems we were working on when I was an undergraduate and got me interested in it just really led me to see that we don't know all the answers. I think sometimes now when we talk to undergraduates or teach undergraduates, you give this impression like we know all the answers and you just have to learn it. And when I began doing research, I really began to saw, oh, you know, that's sort of like not the whole story. There's some really important things and things are changing and we're trying to figure that out. And that was really exciting to me. And so I also had an opportunity to do an internship, and at the engineering company, I interned for the people who were doing the stuff that I thought would be most interesting for me personally. I had PhDs, and they tended to be higher level sort of project planning as opposed to, you know, more down into the project. So for me, I thought then I would go do a PhD and maybe try to rejoin a company like that. But during my PhD, I just completely fell in love with the work, the research, and was fortunate enough to get a faculty job. And that's really the place where you can do this type of research most actively. And so I took it. My first faculty job was at University of Pittsburgh, and I loved it there. I was there for about 5 years and then moved here already about 3.5 years ago. So that's kind of my personal story about how I got where I am.
Yeah, it's really great. Thank you for sharing. So we also asked for you to tell us a fun fact about yourself. You did tell us you like to fish, but I
wasn't quite sure what to say. You know, I love to fish. We have a 2-year-old son, and he was Curious George for Halloween, and I dressed up as a banana. So we have some fun ones. But the one we mentioned that's sort of relevant to the talk today, that's kind of a cool thing too, was actually just this past Friday. I was interviewed by the New York Times magazine about this work that we're going to be talking about today. So that's kind of another cool, relevant, recent fun fact too.
So we'll see your name.
We'll see if they use it. Hopefully they use it, but it's
okay. That's totally awesome.
Yeah.
Totally awesome. That's like celebrity status now, right? Yeah. New York Times. That's awesome. So let's go into our next segment, where what we call rumor has it. So Marianne and I are listening to our friends and family, and they ask us all kinds of questions during the week. So let's consider this one. Can I get COVID from water? True or false?
Yeah, I think this was a good one. So some of the people that are tuning in might have seen some of these news reports of this technology we'll be talking about today, of measuring, really what we're measuring is the genome of this virus in water. And I think the short answer to this is no. The longer answer to this is maybe under very specific circumstances. But I think as a member of the general public, if you're thinking about something like drinking tap water, swimming at a beach, any of the stuff that we think about with water, the answer is no. Okay. And it's really important to remember that engineers put a lot of effort and expertise into designing our water cycle, right? Both drinking water treatment and wastewater treatment. And these processes have always been designed to remove pathogens. And most pathogens that we're interested in removing are far more persistent, tougher, if you will, than the novel coronavirus. So I don't see it as any sort of concern.
Right. If I could just do a follow-up on that. So so you were describing like our wastewater systems here in our country, and that would hold true then for other industrialized nations. What about countries that don't have that kind of sophisticated water treatment? So, that they may have a open pit latrines, for instance. Would you then be able to get COVID that way?
Yeah, well, it would be potentially of a more significant concern. The nuance around this gets around the idea that most people who get COVID excrete the genetic signal in their stool, but there's only been one credible report that they excrete the infectious virus. So this is a little bit of a nuanced detail, but the genome that we're measuring for some of this work that we're going to be talking about in this presentation is not representative of the whole virus that could actually make you sick. It's just sort of a signal that the virus was there. And so it appears that it's plausible that there's very low levels of this virus in wastewater. It hasn't been found yet. And it's plausible under maybe if you're exposed to highly concentrated wastewater that you could get it through this route, but people generally think it's very unlikely. So our group and others are doing research around this, but I think it's important to represent that we think that this is really unlikely. We're doing the research to understand it fully. But for members of the general public, and especially members of the general public here in the US, it's not a concern.
Okay, awesome. Thanks, Kyle, for describing the nuance between these things. That's probably the best word to describe it. So let's consider this week's data. And honestly, you guys, I feel like I'm a little bit of a broken record. I don't bring good news. I think that the last week's data is actually really quite grim. It was on Saturday that Indiana has now reported a new record of 5,000 cases in one day. And then on Friday, St. Joe County reported a record high of 172 new cases. Am I getting a little feedback?
Yeah, I heard that too. I don't know where that's
and
coming
I'm the
from.
one who deals with all of it up here. I'm the one who has to have my meeting in some sort of professional manner.
Mary Scott,
you need to
mute yourself.
She's muted now.
Okay, great, awesome. So where was I? I was just saying that in St. Joe County, we've also had another record day where we've had 172 new cases. And again, since the time that we started this show, we were averaging 75 new cases. So we're at now like 2.5 times. So when I do the tracking the data, I mean, we're on a steep incline for what's happening. And then of course, on the Notre Dame dashboard, as goes Indiana, as goes St. Joe County, now Notre Dame is also seeing these sharp increases. So this past week, we saw an average of 31 new cases per day. And I think on a single day, we had something like 70 or 75 cases here at Notre Dame. So again, with my public health hat on, I have to reiterate that what are the things that are going to make a difference for us? And that is the mask wearing, the social distancing, and avoiding these crowded spaces and places. But Kyle, I was wondering, what is the wastewater testing? What is it that we're doing on campus? So how are you interacting with the surveillance and the testing happening here at Notre Dame? Yeah,
maybe if it's okay, maybe I could give just a quick rundown of what we actually do in the wastewater testing, and then we can go into some of what's going on. So some of you might have seen, of course, I live and breathe this stuff, so I assume everybody's seen it, but some of you might not have seen this. So the basic idea is that if you get COVID, in addition to the virus being detectable in nasal swabs, like if you go to the clinic and get tested, most people excrete the viral RNA, or this genetic signal that I'm referencing, in their stool. And so and this isn't surprising, this has been seen for other coronaviruses as well. And so once at the early part of this outbreak, our group and other groups had this idea that, well, there's limitations in testing, there's this asymptomatic spread, there's all these challenges with trying to understand where this virus is and how much of this virus is there, But if you excrete the virus in your stool, perhaps we can measure the wastewater, and we could use those measurements in the wastewater. And again, we're not measuring the infectious virus, we're measuring, it's called the viral RNA, it's a genetic signal. And we could understand maybe where the virus is, possibly if trends are increasing or decreasing. And we're also working to try and understand maybe if we can use those numbers to estimate how many people have COVID. So this is all active research. This is not like off the shelf ready yet, but that's the basic idea of this approach, that you could use this as an additional source of information in addition to clinical monitoring to help direct public health response. And so we're doing this on campus. And our main part of this campus monitoring is we're actually sampling, it's done by a machine, it's called an auto sampler at a main campus outfall that collects all the wastewater from campus. And we're measuring the levels of the genetic levels of this virus in the wastewater over time. And as you might suspect, recently we have seen some increases consistent with clinical monitoring. Interestingly, other research reports have sort of said that you can find a lot more, virus than you would expect, for example, in wastewater based on clinical monitoring, or you can see increases in the virus in the wastewater earlier than you do in clinical monitoring. On campus, we really haven't found that to be the case, and it's a little bit early, but we think that that's because we've done a pretty good job on campus with clinical monitoring. There's not some big gap of people who have COVID that we aren't finding. It's matching up actually amazingly well, and we're hopeful to put together a paper about that.
Can I have a follow-up on that? So you said you were like sampling from one place on campus. So
that's the main part of our work. We have a secondary thing of trying to sample at individual buildings, but yes, that's right. That's the main part of the work that we're doing right now.
So yeah, because I guess I was going to ask, can you identify, does the biology department have a problem, or a certain dorm, or?
Yeah, that's exactly right. So, to be honest, we've been planning this since May or April or whenever we started sampling locally in the very beginning of March. And we had our first hit, if you're interested, in St. Joe County on the day the first case was reported here too. And that wasn't on campus, that was at a regional wastewater treatment plant. When we were planning that, we're thinking, all right, cases, there's not going to be enough cases that we're going to be able to go and find it at individual buildings. And so monitoring the whole campus makes more sense. Clearly, that's not the case. And at the level of spread we have, well, it's really interesting from a research perspective, monitoring the whole campus, and we've gotten great support from university leadership. It really is really more research driven at this point, because we know that it's here, right? And the clinical monitoring is pretty good. But something that might be more actionable, whether it's a college campus or something like a long-term care facility, congregate care facility, nursing home, whatever you'd like to call it, would be monitoring at a building level, right? And in that case, you probably don't even care the levels of the virus, you just care if it's there or not. Because if you have a building where you're not supposed to have COVID and you have COVID, then we need to test, we need to do something. So we have done that on campus in the past, and we are doing it, planning and working and doing it in the future. And we've had a lot of great developments in making it faster, because the big challenge is you don't want the results in 3 days, you need the results like today for it to be useful. And so we are doing that. And I think that this would really be one of the information streams that the surveillance team would get to direct surveillance testing. It's not the information stream, so clearly people could move around between buildings. So just because you have a hit doesn't necessarily mean that it's someone in that building. So there's all sorts of uncertainty associated with that, but it's something we hope to be able to implement a little bit more fully in the future.
Listening to you talk about this and describing it as using it as a way to detect positive or negative. So is it there or not there? Congregate living, and we think of nursing homes first. But now I'm thinking about, what about jails? in prisons and juvenile detention centers. It seems like a logical place for it to go.
Yeah, it's definitely. And locations like either long-term care facilities or prisons where you have a fixed population are probably the best use case. Yeah. Because if you have a location, for example, this technology has gotten a lot of attention, for example, keeping high schools, but you have this problem that you have a very transient population within that type of building, and someone has to use the facilities. The other area that our group has collaborated on some research papers that have come out is using this on things like airplanes and cruise ships. And those sound very attractive, but again, you have this problem on an airplane. One, someone has to use the facilities, and two, you have a very short window to be able to process it, to be able to make a decision. So maybe it could be useful, but probably not. Yeah. Maybe there's some technology we could think about, but something like a cruise ship would be very useful because you have essentially a fixed population and you have enough time to be able to analyze it.
And so the idea would be then you quarantine them and don't let them dock or something.
Yeah, or we tested on a cruise ship, but you could imagine doing this on a naval vessel as well. Yeah. Or any other situation where you have sort of a fixed population. You could use a technology like this. Yeah. And I also really need to emphasize, I think some of the news stories that have come out, they call this, we're testing the whole population. It's really not that. There's a little bit of nuance in this testing, and it's really should be seen as maybe one of the pieces of information that can be used as not a surrogate for clinical testing or any other information source you could use.
That's such a good point, Kyle, about that this is one metric to be used before to learn about what's going on with COVID. So in terms of like us helping to educate our audience about this, we're constantly driving home the idea that we never use just one metric to make decisions about a community, that it's a collection of things. And so your point is well taken.
Yeah, for sure. I'm going to be interested in reading your paper just because, we did surveillance testing last week and all the undergraduates were tested through surveillance testing. And we identified 61% were asymptomatic. And so I'm just wondering how that's going to correlate to the wastewater testing that you might have done, in the past week, or to see how that correlates with that uptick.
Well, yeah. I mean, so we have seen an uptick. There's some nuance that goes into this too, because some of these cases, depending on where they're quarantined or isolated, are essentially exported off campus. And so one of the things, if they're housed off campus, then we're not receiving that signal anymore. Mm-hmm. And so we're refining our model to account for essentially, and this is all anonymized. We don't know but we do know whether they're on the number of positive cases that are housed on campus, because there's some housing that is on campus. And so we're refining our data to account for that, and we think it might fit better. But even just the number of positives actually fits reasonably well. And has been noted in several emails, there's probably an expectation of more positive cases to come, unfortunately. And we're certainly going to be on the outlook for that in these remaining 2 weeks as well.
Yeah. Sobering news for sure. Yeah. Well, let's transition to our headline section. There are lots of headlines that we can choose from, but I tried to choose a couple that were relevant for today. So I'm going to read two of them. One is from USA Today, and the title is "The Best COVID-19 Warning System: Poop and Pooled Spit," says one Colorado university. And the other is from the Salt Lake Tribune, and the title is "Some Utahns, I guess, refuse to get tested for COVID-19, including a state lawmaker. Health officials are worried." And so in the last one, the synopsis is people will go to physicians to get treated, but they don't want to be tested because they don't want their tests to be included in the rising numbers and schools being closed, or that they would have to quarantine or something like that. So I guess a couple of questions for you, Kyle, is regarding the first one. I imagine you get pretty tired of poop jokes. And
Yeah.
do you think that the jokes around it or the uncomfortableness of people talking about human waste undermines people taking the work seriously?
Yeah, a little bit. I kind of mentioned this when we had met before, that I guess it's only natural. It's, I guess a little bit of an ick factor, a little bit taboo. So I certainly understand, but I personally am not a fan of the poop jokes, because I do think it undermines both the science and the potential of what we're doing. Also, on that first headline, this is one of these cases where I think, the writer, or I don't know where they got this idea, but the best, I would really push back against the idea that this is the best response in the pandemic, especially today with very high cases. I think that it's not a replacement for clinical monitoring. Unfortunately, this virus is endemic, so it's going to be here a long time. Maybe if we drive levels low, it could be, a very good early warning system. But right now, I think that that's a little bit of a attention-grabbing headline, maybe.
Yeah, of course.
Yeah. So that's what I would say about that.
Yeah, I often read like a title from a newspaper article, and I get kind of annoyed because I think it's wrong. And when you read the article is right, but they just sensationalize the title. So I guess as a follow-up to that second one, and you kind of alluded to it. So do you think we can use wastewater testing? Like if people stop getting tested, like they refuse to get tested,
Yeah.
a way we could inform public health policy by wastewater testing?
I think maybe I'll dodge the question a little bit.
Okay.
Maybe I think it could be useful today, maybe not as much, but one way in which this is useful, and I've seen this used multiple times recently, is there's an idea that increases in cases are purely or maybe primarily due to increased testing, right? That there's not really an increase, we just are testing more, and so we're getting more. At some levels of tests, some percentage of increased positives can be explained by this, but it's not the majority of increases. Most of the increases we're observing are in fact real. And one of the best, sort of totally separate lines of evidence of this is if you look in the wastewater, right? That doesn't depend on any new testing. When we're seeing these spikes that are above the March or April levels in some communities, that really sort of refutes this idea that it's not real, it's just extra testing. And so this is a way to kind of maybe convince people, or at least have another line of evidence around this idea of, whether or not you want to be tested, or increases are purely due to testing.
Yeah. So I thought maybe we should maybe give a little bit of history about wastewater testing. So do you think, Kyle, you could, give us the big picture of like, where did this thing come from? How have we ever used it before? How do we know it's effective?
Yeah, definitely. And thanks for reminding me. So it's not a new idea, this idea of wastewater-based surveillance, or some people call it wastewater-based epidemiology. It's been done for other, primarily viruses and some bacteria, including salmonella, for decades, really, and probably most notably for poliovirus, in attempts to eradicate poliovirus. That's not the only virus, but most notably. And so, including most recently in Israel, it was used in 2013, 2014 to detect what was called it's a silent outbreak of wild poliovirus there. And they were actually able to implement a revaccination campaign in that community to avoid any symptomatic poliovirus spread. So for only about 1% of poliovirus infections are symptomatic. So it's a powerful tool there. And in fact, throughout Europe, there are poliovirus monitoring projects trying to detect in case wild type poliovirus would reemerge there. So this idea has taken on new life with SARS-CoV-2 and in response to COVID-19. It's not a new idea. And my hope is that it doesn't become an old idea, because I do think that it this approach could be a useful way to get all sorts of public health information, even after COVID-19, whether that's being ready for the next pandemic virus and being able to detect it very quickly, or monitoring more seemingly mundane pathogens like antibiotic resistant bacteria, or maybe even seasonal influenza. So that's kind of my quick background on the past and hope for the future.
So how sophisticated how sophisticated is this wastewater testing? Can any community municipality do this? Are we doing this here in St. Joe County? Are we doing it at state of Indiana, or?
Yeah, good question. Good question. So I would say it's moderately sophisticated. It's probably a little bit above what maybe a smaller wastewater treatment plant or community could handle. There are contract labs that could do it, but it's probably not so sophisticated that larger municipalities or wastewater treatment plants couldn't handle it. And some are actively doing this. The state of Indiana does have a pilot monitoring project. They're monitoring about 30 municipalities and have been since the middle of August. And we're part of that project. And I heard you mention Alex Perkins, who spoke last week. He's also part of that project as well. And so the idea would be that this could be sort of statewide trend monitoring and early warning system that they're hoping to implement. But at this stage, it's still in the pilot evaluation.
Yeah,
Okay.
I read that the state of Ohio has a statewide program that's similar. Do you know?
I'm not familiar with the state of Ohio, but there's actually a nationwide effort that's being pushed by the CDC as well. These things are all moving so quickly, it's a little bit unclear of maybe who's in charge of some of these efforts, but let's put it, I think that there's a push to try and implement this more broadly, which I think is very positive. Primarily, like I said, maybe not so much today, but following the introduction of a vaccine to monitor for trends, and then hopefully in the future to monitor maybe for other pathogens as well.
Yeah, so when you were talking about the national push, aren't you heading some national research network? Can you tell us a little bit about that?
Yeah. So it's a little bit of a funny story. So my research group primarily studies viruses in water. And so when before there was even cases of COVID in the US, we were in contact with people in China about monitoring for this in water. And when it came here, we, ramped up and began monitoring for it in water very early. And really, we just reached out to a couple of our friends that we basically knew would be doing the same thing because we study, we're colleagues. And we thought it'd be a small group that maybe about 6 or 8 research groups where we could share ideas and methods and try to help things move more quickly. Well, as you might imagine, this has caught a lot of people's attention. And so this network that we've set up now has at least 870 individuals registered all throughout the world.
Wow.
Wow.
Every continent but Antarctica. And it's led to what's called the National Science Foundation Research Coordination Network. And that's really a lot about information sharing and coordinating some of these research efforts. But this has really caught the microbiology and environmental engineering research world's attention. There's a lot of people who are interested in this topic.
So is there, do you guys have a website where community members could go to find information, or?
Yeah, I could put it here in the chat. I think if everybody, all the participants and attendees can see it. So it's
that would be great.
COVID-19wbec.org.
That's awesome.
And we'll make sure we'll post it in the additional resources. So if the audience wants to go back and look at that later, they'll have the link. That's perfect. Yeah.
It's like I said, we thought we were going to set up a Slack page with 6 research groups, and it really sort of exploded.
Sometimes it's be careful what you wish for.
Exactly.
More work than just having beers with your friends.
Yeah.
So I had a technical question, and I can't remember, Kyle, if you mentioned this already, but does everyone shed the virus in their stool? Is that
Yeah.
a given? Okay.
Good question. No, the answer might be some people shed it at levels that are too low for us to detect. The real answer is about, depending on the study or data you look at, about 20% to a third don't shed detectable viral RNA. And so this is one of the many reasons why at this stage, I don't think this should be a frontline defense. So for example, you could have a positive COVID case in a building and not be able to detect it, right? And so when you get a positive COVID, you know it's there. If it's a building where people can move around, come in and out, then there's that sort of uncertainty associated with that as well. But just a negative doesn't mean that no one in that building has COVID.
Okay.
Yeah,
Awesome.
can you just tell us a little bit more about how the sampling is done? Is it like a machine, or do you go and dip out of some pool of wastewater, or how?
Yeah. So for most of the sampling, it's done by a machine, and then we just handle the bottle, and that bottle is handled in biosafety hood, and it's processed in the lab. We also have been developing a passive sampling approach, let's call it, using gauze essentially. And other groups have been doing this as well, throughout the country, and this is our world really. And this is one of these benefits of this collaborative approach. But it gets down to the idea, if you're monitoring at a building level, you don't care about the precise measurement of the count of virus. You just want a positive or negative signal. And so then we can just take this gauze that sort of maybe absorbs some of that signal and process it without the necessity of installing an expensive machine or having personnel there to grab that sample all the time. And so this is one of the things that we've piloted. It works, and we're hoping to implement more fully in the future.
Yeah, it's all pretty interesting.
Sure is.
So you'd mentioned when you were talking about the history, and I think also a little bit in your introductory comments, but what other pathogens besides viruses are regularly tested for in wastewater plants, like to help keep us safe?
Pathogens, really none.
Okay.
So we don't really, in most water quality applications, measure pathogens. There's simply too many for us to be able to detect them all.
That makes sense.
And so the approach we use is called the indicator paradigm, and what we typically measure are called fecal indicator bacteria. Okay. So you might have heard of measuring levels of E. coli, and we typically associate E. coli with getting sick, but those E. coli we're measuring most likely won't make you sick. We all have E. coli in our gut. What we're measuring is an indicator. Have we removed the things that we're most concerned about? Now, my group also, one of our pre-COVID or still ongoing, primary research things is developing better indicators because there's some problems with using E. coli, for example. They don't represent viruses very well, right. But that's what are monitored for and regulated in most cases.
Do you think you had mentioned a minute ago about the next pandemic? Can you talk a little bit like how you might be able to monitor wastewater to predict that we're going to get another pandemic? Like, can you identify viruses that we don't know about yet?
Yeah, well, so this is an idea that's ongoing. I don't know if wastewater would be the best source for that, because by the time you measure it in wastewater, it's already in the human population. And so, if you think about the next pandemic, it's probably going to be a zoonotic pathogen. If it makes the jump, we're already there. So, but there are ways of using something called metagenomics, which is random DNA sequencing, to look for novel viruses. And then there are ways to predict which of those maybe have the most potential to jump to humans. So typically these efforts have focused on monitoring likely animal populations like bats, but there have been ideas to look for some of these maybe not novel viruses, but maybe novel strains of some of these viruses in wastewater. And then that also is highly relevant with something like seasonal flu, where we want an early warning of novel strains coming up. So I think it would depend on your application whether wastewater is the best source, but there are definitely people that have put a lot of effort into looking at this.
Yeah, so actually I asked that before somebody submitted a question before I saw the question. So
Right.
Oh, great.
Beidinger-Burnett anyway says, hi everybody, thanks for the opportunity. And then asks the question if metagenomics could be applied to SARS-CoV-2 to be a complementary tool to the wastewater surveillance.
I think it really could. And there's been some preprint type papers, I think that should be accepted soon, looking at variants of SARS-CoV-2 within populations to try and understand maybe where the spread is coming between communities. Despite what you've seen in the news, SARS-CoV-2 doesn't evolve very quickly, person to person. All viruses evolve, but this actually tends to be a pretty slow moving one. And so these strain variants aren't as useful as they might be for some other viruses. But that's definitely something that people are working on.
Yeah, for the audience, SARS-CoV-2 has basically an editing function. So if it makes a mistake when it's replicating, its genomic material, it can correct it. And so that's why it doesn't mutate as fast as something like influenza, for example. So I guess we do need to be taking some questions from the audience. And so that was the first one. So this one is from Natalie Myers. And she asks, can you help us understand when and how often and with who the results of the wastewater sampling are being shared? And I think they must mean on campus.
Yep. Okay, yeah, so I can see the question too. So
okay,
the data is being shared with a fairly broad group of university administrators, some other faculty members who are interested, and also members of the team that help to direct surveillance testing. I am completely open to making the data open and shared. A few universities have done that. I don't think most that are doing this have, but I wouldn't really have a problem with it. The one challenge is there's a bigger lag with some of this testing than clinical testing, just given essentially the fact that we're a research lab and our ability to have the throughput. But I think it could be. There's also some maybe more nuance in some of this, and there's concern about maybe misinterpretation of some of this data and how do you present it most clearly. But I personally wouldn't have any problem with that. And you know, even just seeing the detection going up and down, the nuance with this is this data tends to be noisier, and so there's some of our main research goal right now is essentially looking at normalization factors or smoothing functions, so that when we see apparent increases, we can be sure more quickly that this is a real increase and not part of the noise. And so, you know, I think if you have the last data point that looks like a big jump, but the next day is back down, you know, there's a possibility for misinterpretation. But that's not the reason we haven't been reporting it. I think the reason we haven't been sharing it more broadly is we all just got kicked in the teeth this semester and we're trying to keep up. So I personally wouldn't have a problem doing so in the future.
Yeah, maybe the long break will help us all get caught up.
Ooh, you said it. Kyle, I was just going to follow up. How many universities in the United States are doing similar work that you're doing?
I don't have a good number. If on that website I said there's a map that probably has a good number. And
okay.
it probably is incomplete. If I had to guess the number of universities that said they're doing this, I'd guess maybe 100 or more.
Okay.
If I had to guess the number of universities that are doing this sort of full force, maybe 1 or 2 dozen are doing this. there's kind of different levels, I would say, of engagement. You know, for example, I mean, weekly grab sampling versus sort of daily or more comprehensive sampling. So there's probably at least 100.
Okay. Yeah, and that's where I was going to go next was, what are some of the big lessons that are being learned? And is that information just readily being shared? I'm assuming through your network it's being shared. But what are the big ahas that people are having with regard to wastewater testing?
Yeah, I think one is this community generally is a very open community. And so, you know, in academia, you know, sometimes there's competition and people don't want to share their data or their findings. And both in this community and also in the case of this work, people have been extremely open. And so this data is being shared really quickly on, there's a Slack page for those of you familiar with Slack. There's a similar thing called protocols.io for those that are familiar, and it's all being shared really, really quickly. And then there's sort of informal video chat meetups where people just talk their problems out, and it helps everybody move along more quickly. There's been some little technical, you know, sorting out, but that's probably not most interesting for folks. I think the most interesting things that we're finding that we didn't expect when we started this setting up for the semester is this idea that we really need to move down to building level testing for this to be useful. I think everybody was really kind of, at that time, there was kind of this lag in the summer where cases were not real high, maybe an optimism that, you know, or assumption that universities would have to keep cases very low. And this idea that then that maybe building level testing would be kind of missing the point because there'd be so few cases. And now it's quite clear for us to be able to do anything with this information in the near term, we need to be monitoring at building level. And then some of these ideas of how do we, all right, monitor at building level, but do it quickly, you know, and do it in a representative way. So there's some of these advancements as well.
Yeah.
Is it expensive to do this kind of testing?
It doesn't have to be. Just to throw, there's a contract company, a very well-known company that's doing this for cities now. They're charging about $1,200 a sample. So that is
$1,200 a sample?
Yeah, that's expensive.
Okay,
But
that
for
sounds
us,
expensive.
that it is. But, you know, we could do it, not including personnel time, you know, for some of these passive samplers on the order of $10 or $15 a sample, which is cheaper than a clinical nose sample. So a nose swab, depending on who you ask, is like $19 or something. I don't know.
Yeah, I suppose the company, they have to account for their salaries, their benefits, and all of that when they're doing their cost structure.
There's a, yeah, I mean, there's a lot of people trying to do different types of levels of startups and things around this technology, for sure.
You mentioned something when you were talking about the different websites, and it goes to one of the questions that was submitted by Edward Kukla. And so he's basically asking, is testing wastewater is a chain of procedures that is complex? And is there any documentation or library that exists giving the appropriate instructions? So maybe your websites that you talk about.
There's no standard, and that's a problem, right? It's the Wild West. Everybody is talking, and we're not going to move towards a standard really quickly. This makes it harder to communicate this to public health officials that are used to very rigorous clinical standards and, you know, and interpreting some of these values. And I think that is an issue. And I think the broader issue is then how is this communicated to public health officials, you know, if it is, and how is it communicated in a usable fashion? And that's something that we're probably not at yet today, because if I give you a concentration of SARS-CoV-2 in your wastewater, there's no action level. It's so what do we do with that information?
Right.
You know, and I think that's a really important issue. I'm part of a Sloan Foundation funded project that's exactly focused on this. Like, sure, the researchers are interested in the technical development, but how do we make it actionable? How do we communicate that information? And there's people working on that, but we're not there today. That's for sure.
Wow. I think I had just one more question. Kyle, what are some of your go-to sources for COVID data? So you wake up in the morning, you're having your coffee or whatever to get yourself going in the morning. What are your go-to sources to keep yourself informed about what's going on?
Well, I'm on Twitter, I guess. I'm on science Twitter. I don't use it personally, really, but I selectively follow other scientists, and they, follow me, I guess. And you go there, and the conversation tends to be pretty technical, and I like that. And that's one of the best resources that I have found for keeping up to date on areas that are not in my primary technical expertise.
Okay, that's awesome. We haven't heard this one yet. So that's a great resource then for our folks. And now I'm going to show my ignorance here. Science Twitter?
It's the same as Twitter, but I don't follow politicians or
so you're
movie
specifically
stars or any.
following the
I follow others.
folks.
Yeah, people joke around, call it science Twitter. So a lot of scientists tend to use it as a social network. It's a useful way to advertise when papers are published and to have some of these discussions. That's
awesome. Awesome. Well, do we have time for one more question?
I think we have time for one more. So
okay.
Beidinger-Burnett maybe said, would it make sense to test the wastewater of a hospital since they have exact numbers of infected patients? So that was interesting.
Yeah, I think that's a great idea. And we've done similar things at isolation facilities as well, but that's a great idea to try and understand shedding rates and observe shedding rates. I didn't really talk about this, but shedding rates, or the amount of this viral RNA that a single person excretes, varies widely, more than 1 million times. This is one of the challenges with this technology. Monitoring at a hospital might be a way to get around that. I think that's a great idea, and thank you for the suggestion.
Oh, that's great. I'll send you her name afterwards so that you can acknowledge her when you get your next grant. Before we go to the lightning round, I want to address one more question, and I'm going to answer it. And it's from Edward Kukla, and he writes, after the football team won their last game, the stadium suffered from a rather large violation of social distancing rules. Are you going to change the frequency and or distribution of your sampling after this event, on campus and off campus? And so I thought that that question was probably going to come today. And so I just want to inform the audience that before the football game, all the students, well, not the ones that had already had COVID or were in isolation, but all the other students were tested the week before the game. And so if they tested positive and their contacts had to, so if they tested positive, they went into isolation and their contacts had to quarantine. And if they didn't come for surveillance testing, they were not allowed to go to the football game. And we had 98% compliance. So the vast majority came, and the ones that didn't come were not allowed to go to the game. So hopefully most of the students, I mean, we can't catch everyone, right? But most of them that were there were negative. So the other thing is, if you look at the video, that mass mob, a lot of them had masks on. So at least there's that. And then we are doing exit surveillance testing. So all the students will have to be tested before they leave campus and go out into their communities. And if they don't, then they're not allowed to register. There'll be a hold actually put on their, they can't get transcripts or anything like that. So those of you out in the broader community, will be testing all the students before we send them home. So with that, should we go to the lightning round?
Yes, absolutely. So Kyle, we do this thing called the lightning round where we ask some fun questions because we like to get to know our guests better, but we know our audience likes to get to know our guests also in a different way. I'll ask the first question. So Kyle, what is your superpower?
Oh gosh, I should have thought of this when you all were doing it. I'm gonna say at the end of the semester, endurance. You know,
That's a good one.
I've always, when it comes to even sports, I was a swimmer. Now I like to run, not super long, but endurance. And you know, in research, I think people imagine it's like a light bulb going on, but really it's probably more akin to like a marathon. And so I'll say endurance.
Awesome.
Okay, what was the last show that you binged and loved?
Well, I don't know about binged, but my wife and I just watched the new Mandalorian Star Wars show last night. I guess there's 1 or 2 new episodes, and I really enjoyed that. I guess a little bit nerdy, but so I'll go with that.
Okay.
Awesome. Kyle, what is your most treasured possession?
Oh my gosh. My most treasured possession. All right, we'll go with the wedding ring.
You're well trained.
Yeah.
Okay, what about your favorite meal?
My favorite meal. There's a restaurant down in Florida where my family likes to take vacations, and they have they call it Yucatan shrimp, and it's sort of like spicy shrimp and butter sauce, and that'd be it.
Well, you can't
Some
go wrong.
garlic bread and spicy shrimp.
That sounds awesome.
For dinner.
And then the final question is, what are you deeply grateful for right now?
My family, I think. You know, maybe many of us have, between quarantine when we were completely locked down and now when you're spending much more time at home, hopefully have used it as an opportunity for renewed appreciation of, you know, just what's around us and spending some time outdoors and that type of thing. So I'll say my family.
That's awesome. Well, see, now we got to know you a whole lot better and in a different way too. So thank you very much for that.
Yeah, thank you for having me.
Being a good sport.
Yeah, really, thank you very much. It was fabulous. And I just want to encourage our audience to share the information that Dr. Bibby imparted to us. And anything you learned today with your friends and family. And again, if you have any rumors that you want us to address or topics or future speakers, please email us at consider@nd.edu. And I hope you tune in next week when we will consider populations that have been especially affected by COVID with Deborah Stanley, the director of Imani Unidad and the St. Joseph County Sheriff Redmond. Consider this, the more you know, the more good you can do.
So be informed and act on accurate information.
And share reliable information with others.
Until next week, be kind and give grace to each other. Bye, everybody.
Bye, everyone.